Good morning, my YouTube viewers. Crystal here. I'm here this morning to give you another cold review. I've been doing some more work on the Titanic, and I just wanted to show the work that I've been doing. I'm probably going to make this notebook public if people want to look at it. I made one of my notebooks public, but I'm going to go ahead and make this notebook public as well. So I did some more work on the Titanic data set with the Kaggle Titanic competition. So I just wanted to show you the score I got, 77751. I think that was probably the highest score I've ever gotten, or maybe the penultimate highest score I've ever gotten. But just to show you what I've been doing, I've been working a lot. So my final score was 77751, but you can look at my list of submissions and you can see how the things that I do change my score. As you look at my submissions, you'll see even if I made, just like a really small change, a really minor change, it would have the effect of changing my score. And I do believe 7751 is the highest score I've ever made, as you can see. So what I wanted to do now is I wanted to go over my notebook with you with the Titanic competition, because I've been working on it a lot. As you can see, I've been working on it a lot. What I'll do here is I'll share my notebook. So if you want to look at my notebook, you can, because you can see that my algorithm did work. I got it to work. So it is a usable algorithm, and it will get you on the leaderboard. It definitely won't get you on the top of the leaderboard, but it will get you on the leaderboard if you want to use it. And I've done a lot. I just showed you all my submissions. So I've done a lot to get it this high. And so far, I've never been able to get it any higher than that. But from what I understand is that most people can't get it any higher than around 85. And then if it goes above 85, then what that means is the individuals have actually gone into the internet and have researched the survivors, and they have fitted the algorithm to survivors to get them 100%. And strictly speaking, that's not what you're supposed to be doing. You're not supposed to fit your algorithm to the survivors, but that's basically what people who score 100% are doing. They're actually overfitting their model. So my model isn't overfitted. So I did actually have to use someone else's algorithm on this. It was someone on Kaggle, but the only thing that I used was just the actual algorithm itself. I didn't use anything else. All of the preparatory work was my work. All of the file preparation and preparatory work was mine. So the only thing that I had to use was the actual decision tree algorithm, because I wasn't getting a high enough score using XGB classifier. So I thought, well, let's see, what can I do to get a higher score? This is also on GitHub if you want to look on GitHub, and the title is Titanic Decision Tree. So I've imported all of these libraries. I probably imported more than I needed to, but that's just, I use old libraries. Sometimes I'll go through and I think, oh, I don't need that, and then I'll delete that. But quite often I keep them all in, or if I know I'm not going to use something, then I'll delete it. But other than that, they all stay in. So then we imported the files on Kaggle. We read the files on Kaggle. We read the train file and the test file. So you can see the train file here and you can see the train file info here, and you can see the train describe. You can see the test file. You can see the test file info, and then you can see the test describe. So what we did here was we did put some code in to see if there were any null characters. And so you can see that there's null characters in cabin age embarked in the train file and cabin age and fare in the test file. So what we had to do was we had to fill up those null characters. So cabin fare and embarked were filled with the mode, which is the middle of the data frame, and the meet and the age was filled with the median. So basically you can't work on a data frame if it's got null characters. Quite often the system won't work, the program won't work. And then I did a test to see if I had any null characters, and no, I didn't have any null characters. So now you can see the train file and you can see the test file with all the null characters replaced. So now what we're going to do is we've taken the title out of the name column, and so I use an algorithm to take a title out of the name column. So we split it. So that's how we did it. We split the comma and the period to take the title out of the name. And this is one thing that happened. It said, this is what we came up with when you came up with when you did a group by the title and the name. And one thing that I'm going to tell you is this computer missed out a Donna. I don't know why it missed out a Donna. I don't know if it's because it didn't have a period or a full stop after it, but it missed it out. And then I found out because I had a null value, and I had to go find out what the null value was. And then when I found out the null value, I found out that there was a title called Donna, and I think it was on row 414, I believe. It was on passenger 414. And so when I found it, I put it into my dictionary, and then I mapped the dictionary into the train file and the test file. And then we did another test to see, and it all came up again in numbers instead of strings. The next thing what we did was we tested to see if there were any null characters in title, and there were not any null characters in title. And so it's always a good idea if you're create a new column or you're manipulating a column in any way to go through and see if there are any null characters, because sometimes a null character will be put in there. And what I found is the software works differently because I was using Google Colab, and Kaggle is a lot more forgiving than Google Colab, because I transferred this code over to Google Colab, and Google Colab would go into error, but Kaggle wouldn't. So I had to try to figure out how to keep Kaggle from going into error. And I was able to do that because when I was in the military from 1979 to 1994, I started out as a wideband maintenance equipment repairman. And then, no, I wasn't. I was radio relay equipment repairman. And then I became a wideband maintenance equipment technician. And so I had to troubleshoot equipment. So I had this, because I had been troubleshooting equipment for 15 years, I have the ability to troubleshoot code, which is good because quite often you get code that doesn't work, and then you have to troubleshoot it and find out why it doesn't work. Or you'll get code that'll work on Kaggle, but it won't work on Google Colab. So you've got to troubleshoot Google Colab to find out why it doesn't work, and then you have to input extra code, which is what I had to do on Google Colab to get this same code to work, to get this same algorithm to work. I had to insert extra code into Google Colab just to get it to work. So Kaggle is a lot more accepting of errors than Google Colab is. That's one thing I found out. So now we have a graph on the passengers class, and you can see that the majority of the tickets were third class tickets. So, and then what we see is the survivors on the first class, the second class, and the third class. So the majority of the survivors were in first class, and second class and third class didn't fare as well. So again, what we did was we just did a test to see if we had any null characters, and no, we didn't have any null characters. The next thing we did was we checked the sex. So you had a male and females, and you had 233 female survivors and 109 male survivors. So that means that more females survive than men. So if you were a woman, you had a greater chance of survival. And then so what we did was we did a test on the ratio of male and female on the ship, and you had like almost twice as many men as women on the ship, but you had more women who survived than men. So we mapped the male and females. We gave men a 0 and female a 1, because women were more likely to survive. And then we grouped it again, and you can see that males were 109 survivors and females were 223, because this algorithm works on numeric values, which means we have to convert all of the strings to numeric values to get this algorithm to work. Then we went through the ages. People were like newborns to 80 years old. And we plotted a graph from the ages, a violin chart, and you can see the median age was in the late 20s. And then so we plotted another chart, and again, you can see the median age, or the most people were from 26 to 35. And then what we did was we segmented the ages. I went ahead and segmented the ages, and I divided it into child, young adult, middle-aged, and pensioners. So you can see right there, we had child, young adult, middle-aged, and pensioners. And then I had to create a dictionary, so to assign a number to all of these characteristics. And I had to map it in the train file and the test file. And then again, what we had to do was we had to do a test to see if there were any null characters. So we did another group by on our age range, and you can see the age range there. So the next thing we did was we did a check the family size. And I did something else, because this one person who's just a little bit of the code that I borrowed from him, he had combined the sib spouse with the part, but I wasn't able to do that. That just messed up my readings totally. So I kept the sib spouse separate from the part. So this was your family size. That means sib spouse. That means if you had any siblings or spouses with you. We plotted a figure on that, plotted a violin chart on that, and you can see that the people who fared the best were the people who were single. The people who were traveling on their own were the ones who fared the best, because they didn't have anyone to think about. They only had to think about themselves. And so those were the people that had a greater chance of survivor. Well, people who were single, they didn't have to worry about saving anybody else. They just had to save themselves. So the same thing was parch. Parch means, I think it means parent-child. And what someone else had done was he had combined sib-spouse with parch. But I decided not to do that because when I tried to do it, it just messed everything up. And I decided to keep it separately. So you can see a violin chart. And again, the people who had the greatest chance of survival were the people who were single, people who were just on their own. They didn't have to worry about saving anybody but themselves. They had the greatest chance of survival. So now we did a group by of the fares, and you can see that the fares range anywhere from 0 to 512, I believe it was, pounds. And back then that would have been a lot of money. And so again, what we did was we did a violin chart on the fare, so you can see that. What we did, because there were so many fares, what we did was I created segments, and I segmented the fares from 0 to 99, 100 to 199, 200 to 299, 300 to 399, and 400 plus. And then so I mapped, I created these bins and put it in the files, created a new column called fare range, and that's what we were going to use. So we did a group by on the fare range, and you can see that it was a lot different. You only had 5 categories instead of a different fare for everybody. So what we had to do was we had to create a dictionary with all of the categories and assign a category to a number and map the train file and the test file. So that's what we did. And again, what we did was we tested this column for any null characters, and there were no null characters. But I think what I did was originally, whenever I was first working on this, there were some null characters. And so I had decided to just go ahead and create this code to replace any null characters. But there shouldn't be any null characters really, because you should take care of the null characters at the very beginning of the program. And if you get null characters later on, that means there's a problem. And I had to correct the problem. I'll tell you how I had to correct the problem. It was right here. I had to put a -1 here, because if you put a 0, then you're going to get a lot of null characters. So anytime you have a 0, put a -1 in there, because if you don't put a -1 in there, then what's going to happen is you're going to get null characters, which is what happened to me. But I just didn't take that code out. I left the code in. The next thing we did was we did a group by on embarked, and you see that there were 3 embarkment locations. So I created a dictionary, and every location was given a number, and I mapped the column with those numbers. And that was it for manipulating the data or cleaning the data up, because you have to make sure that the data is clean as possible. Because if you've got null characters in it, then the program won't work. And if the data isn't cleaned up, then the program won't work as efficiently, because you'll have a lot of noise in the program, and then the noise is just going to make your accuracy go down. So you need to make sure that your data is as clean as possible. But what we've done is we've completed the processing the data and cleaning the data. So we put in some more coding to see if there are any null characters, see if anything was dropped out, and there's no null characters in the train file and no null characters in the test file. And just to be safe than sorry, we did another test on null characters, and it said 0, 0. So this is your train file after it's been cleaned up, and this is your test file after it's been cleaned up. And these are your train data types. and your test data types. So your data types have to be numeric. If they're going to be going through this decision tree, your data types have to be numeric. If they're not numeric, it won't work. The system will crash. The next thing we did was we plotted a heat map of the survivors, so you can see that. And we had to drop some elements. We had to drop the name, the ticket, and the cabin. If you don't drop the name, the ticket, and the cabin, then the program won't work. So, and then we set up our Y value, which is trained, survived, and we set up our features, which is P class, sex, embarked, title, age range, SIB spouse, parch, and fair range. We set up our X value and our X test value. So you can see what X is because I wanted to see what X was. You can see what X test is. And now we use this code to train the data. And that was the code that I had to borrow from somebody else. But I still had to input some information in there to get it to work. And basically what you had is like this training the data. It was going through the different rounds to checking for the accuracy. And they decided the depth that had the best accuracy was depth number 3. So we put in this other bit of code and with the decision tree and gave it a max depth of 3. And then what that did was that created our submission file. And when we created our submission file, we submitted that. You can see we submitted that to Kaggle. And that's exactly what I did. So that concludes this test review. So I hope that concludes this code review. So I hope that is of help of you. I've made this notebook public, so you can always look at it to see what I did and borrow the code, because I made the code as simple as possible because I was reading somewhere that said you need to make your model as simple as possible, because the thing is if you make your model really complicated, then you're not going to be able to figure out what you did wrong, and somebody else is not going to be able to figure out what you did wrong either. And I had to borrow the decision tree algorithm from somebody else in Kaggle because I was using the XG classifier and XGB classifier, and it just wasn't giving me the results that I wanted. I wanted to improve my score, but this is the highest score I've ever been able to get, but I'm still working on it. I'm still trying to improve my score. So if you like my video, please like, subscribe, and share. And if you like the work I do, I've got my email address down below for my PayPal account, because I don't have enough subscribers to get monetized, and that's why I have to ask for donations. But they would be very gratefully received to help me with my many living expenses. And also at some point I'm going to have to get a more powerful computer so I can get involved in deep learning. And thank you so much for watching this video, and I look forward to making another one for you.